Back. This is lesson 1.4, part 2. We were talking about the greatest common factor and the distributive property. This is the extra sheet of paper that I gave you. This was not in your math journal to begin with. When you're done today, I want you to put this next to the other 1.4 lesson. It doesn't have a page number, but it'll just have to fit in there. Okay, I will be able to find the greatest common factor of two or more numbers. And with that greatest common factor, I will be able to use the distributive property. This is a typo, so go ahead and cross that out. I will be able to use the distributive property. Okay, our vocabulary for this lesson. We have factor. Remember, a factor is something that is being multiplied with something else. Greatest common factor, which is the largest factor that two or more numbers share in common. And the distributive property we haven't written in our math journal yet. There's not a place on our vocabulary sheet, so I put it right here. All right, the distributive property is a property that allows factors from the outside to be multiplied with each term on the inside of grouping symbols. Symbols are things like parentheses, brackets. As long as it is a sum, which means that you're adding things together, or a difference. You can't use the distributive property on anything that isn't a sum or difference on the inside of the parentheses. Okay, difference is subtraction. So, example, we can use it on here. This 3, there's not a symbol in between here. That means 3 groups of everything inside the parentheses. Because of that, that means I have 3 of these and 3 of these. We are multiplying. So, the distributive property states that we can take 3, multiply it to the first term. So that's why we're going to say 3 times 13 right here. We can also, then we can add that to 3 times the other term, which would be 4. So 3 times 13 is 39, and 3 times 4 is 12. So this can be rewritten as this sum. And then, of course, you could add it together to figure out what you have. But sometimes this is going to be useful to us. Okay, factoring. Factoring is to use the distributive property backwards. And pull out a common factor to create with grouping symbols, such as parentheses. So think about what we just did. Up here we multiplied 3 to this and 3 to that, and we ended up with 39 plus 12. Well, what we're going to do here is we're trying to figure out what can go into both of these. So this is where our greatest common factor comes in. So what is the largest number that goes into 63 and 45 evenly? What is something they share in common? Okay, you can look at your times table chart. Sometimes that's helpful. Okay, in this case, 63 and 45. 63 is made up of 9 times 7. So all we're doing is changing 63 into 9 times 7. You agree with me that 63 is the same as 9 times 7? Okay, then we're subtracting 45. And 45 is 9 times what? 5. So 63 we just rewrote as 9 times 7. And 45 we just rewrote as 9 times 5. They're worth the same value. Now, how this is going to be helpful to us is if we're trying to figure out how many groups we can make out, that would mean that there would be 9 groups. So we're just pulling that factor of 9 out here. We can write a time sign here if we want to, or we can just leave it right next to the parentheses because that means multiply as well. So to check ourselves again, 9 times 7 gives me 63. 9 times 5 gives me 45. So that is how factoring works. We found a common factor. They both had a common factor of 9. And we said, okay, we can make 9 minus 5 from this number. All right, so distributive property can only work if we have multiplication with a sum or a difference. So down here it says, can the distributive property be used to simplify each expression? Why or why not? So looking at this one, it has to be multiplication on the outside of the parentheses and a sum or difference inside the grouping symbols. So, no, that is timesing. So this is no, because multiplying in the parentheses. I'm just writing symbols. Also, because this is adding outside. So there's 2 reasons that one isn't going to work. Okay, how about this one? We have multiplying on the outside parentheses, so that part's good. Inside, do we have a sum or a difference? Nope, we have a division problem. So once again, this is a no. Why? This one is because division in the parentheses. Okay, how about this one? We got timesing on the outside. Do we have a sum or difference on the inside? So yes, the distributive property would work here. We are multiplying a difference. Okay, how about this one? What does the 1/2 on the outside mean? Okay, it doesn't have to be a whole number. This means 1/2 times what's in here. So, are we timesing 1/2 to a sum or difference? Yes. So it can work here because we are multiplying a sum. Okay, let's look at this one. 16 divided by, in parentheses, 4 minus 1. Okay, we have a difference on the inside. That's good. Here I'm doing 16 divide by that. On the outside, it has to be multiplication and multiplication only. You're distributing multiplication to each one of those. We can't distribute division. So this is a no because we are dividing the stuff inside the parentheses. Okay, so it has to be multiplication on the outside and plus or minus on the inside. Now, I want you to realize I'm going to add one little note up here. Will you please write down this example with me? Would this one work? Plus 3, and then put a 4 on the outside here. Would this one work? So on the inside, I have a sum inside the parentheses. That's good. What is this 4 doing on the outside of the parentheses? This 4 means multiply. So am I multiplying a sum or difference inside the parentheses? Yes. So this one would be yes. Because we are once again multiplying a sum inside the parentheses. All right, so now that we've done that, we're going to use the distributive property to rewrite each product as a sum or difference. So here, this means we have 3 groups of 12 minus 5. That means 3 times all of this. So we're going to distribute. We're going to do 3 times the first term. So that would give me 3 times 12. Then we're going to subtract 3 times the other term. So 3 times 5. Now we're going to make it just a difference, which means we're going to do 3 times 12, which gives me 36. Subtract 3 times 5, which gives me 15. Now we've written this as just a difference. Okay, let's try this one. 1/3. So we're going to do 1/3 times 18. 1/3 of 18. So let's write that down. 1/3 times 18. The symbol in the middle, so it's a sum, so we're going to add it together. And then 1/3. See how I'm timesing both of them by 1/3? Times 24. Okay, when multiplying fractions, remember we can turn our whole numbers into improper fractions. Okay, that's going to give me 18 divided by 3. 1/3 of 18 is 6, plus 1/3 of 24 is 8. We have rewritten our product as just a sum. Okay, we can even do it with decimal numbers. 0.5 is the same as 1/2, so we're going to do 0.5 times 30. Minus, distribute to here as well, 0.5 times 20. Okay, 0.5 times 30 is 15. Minus, give me 10. We have written this as a sum or difference. Now, how is this going to affect me with the greatest common factor? So here it's asking us to use the distributive property and the greatest common factor to rewrite each sum or difference as a product. So this is where the greatest common factor is going to come in for us. So what is the greatest common factor of 48 and 56? Okay, on some of these easier ones, it's nice to be able to just look at the multiplication chart. And looking at the multiplication chart, what goes into both 48 and 56, unless you already know. Okay, the greatest common factor, or the largest number that goes into both of these ones, is 8. So because of that, we want to turn this into what it is as times 8, and what's this times 8? So 48 is made up of 8 times 6. So write 8 times 6 underneath. All you did was turn 48 into a multiplication problem here. 56, what times what gives you 56? 8 times 7. Now, if we want to turn it into a product, we're going to pull out the common factor. We're saying, okay, if this is 8 groups of 6 and this is 8 groups of 7, that means I can make 8 groups total, and in each one, there would be 6 of this item and 7 of this one. So a good example of what I'd use, where you might use this at, is let's imagine you have 48 Jolly Ranchers and 56 Tootsie Rolls. And you want to make gift bags for your friends. But you want every friend to have the same. You don't want one friend to get more candy or less candy than the other. You want them to get the same amount of each one. So you're trying to figure out, to make it fair amongst all the gift bags, how many could you split it up into? Well, they both split into 8 groups. So, in other words, you could make up to 8 gift bags. Now, what would be in each one? If this was the Jolly Ranchers, you could put 6 Jolly Ranchers in each person's gift bag. And if this was the Tootsie Rolls, you could put 7 Jolly Ranchers in each gift bag. So that's how this could be helpful. You made 8 groups, and in each group, There's 6 of this and 7 of that one. Okay, let's try this next one. Looking at 120 and 84. Okay, if you're not sure what the greatest common factor is just by looking at them, remember the ladder from yesterday? Okay, this could be quite helpful. Into 120 and 84. Well, I know that 2 does because they're both even, so I'm going to divide this one by 2, put a star by it. 2 goes into 120 60 times. 2 goes into 84 42 times. Oh, 6 and 42. I know that 6 goes into both of those, so I'm going to start and put a 6 here. 6 goes into 60 10 times, and 6 goes into 42 7 times. These don't share anything in common, so my greatest common factor is going to be these multiplied together. So 2 times 6 gives me 12. So the greatest common factor of these two numbers is 12, if you didn't see that on your own, which is okay. That's why we gave you tools yesterday. All right, so we're going to turn each of these into something times 12. 120 is 12 times 10. And look at that right there. Do you see where you can get that from? So we got 12 times 10 minus, oops, got to tilt that a little bit, 84. So I can make 12 groups and there'd be 10 of these in each group. I can make 12 groups of 84 from 84 and there'd be 7 of these in each group. So I could take and make 12 groups, and in each group there would be 10 from this number minus 7 from that number. You just turned a sum or different into a product. Okay, 18 and 54. I'm going to do the ladder again. Some of you can see it, and that's great. If you can't, do the ladder. So I know 2 will go into both of them because they're both even. So that gives me 9 here. 2 goes into 54. Let's see, half of 50 is 25. So that'd be 27. Oh, 9 and 27. 9 will go into both of those. So I'm going to put a star and put a 9 here. 9 goes into 9 one time, and 9 goes into 27 3 times. These share nothing in common, so we're done. My greatest common factor is 2 times 9, and 2 times 9 is 18. So this one is made up of 18 times 1. 54 is made up of 18 times, we can get it from just right here, look at that, 18 times 3. Now that means we can make 18 groups, and there could be 1 of this in each group and 3 of this in each group. So when we distribute it back, it'd be 18 times 1, which would give me 18, 18 times 3, which would end up giving me 54. I want you to realize you can do this with more than just 2 numbers. You just have to find the greatest common factor of all of them. Okay, 36, 24, and 42. That one is a little easier for some of you. If you look on your times table chart, you'll see that they all have 6 in common. 6 is the largest number that goes into all of those. So since I already know that my greatest common factor is 6, that means I'm going to turn this into something times 6. So 36 is the same as 6 times 6. Plus, this one would be 6 times 4. Minus, this one would be 6 times 7, because 6 times 7 is 42. So if we're doing all of this, they all have 6 in common. That means I could make 6 groups, but each group would get 6 from the first number, plus 4 from the second number, minus. And that's how you use the greatest common factor in the distributive property to rewrite sums as differences, sums and differences as products. Okay, rate yourself on this concept. Do you feel 0, 1, 2, 3, or 4? Take a picture of it and you're going to turn it in on Google Classroom with your math menu.